Yeah, good morning, ladies and gentlemen. You're all welcome. How was the night? Hope it was fine. Yeah, please try and remind those who are not here. Remind them of the class this morning. I know very well that in our last class, we were about to solve one problem before they took the lights. I'm very sorry about it. Uh, this morning we'll continue with the problem, and I would like to do small revision to refreshing up your brains, your memory rather, so that anything you are going to do will flow. Is that clear? Please, I want you guys to like. It's okay. In our last class, I told us that if we integrate the y, it means y plus a constant, two of us. Likewise, if we integrate the x, this is the same thing as what? X plus any constant, right? Okay? Then I said if we integrate 1 all over x dx, this will going to give us in x plus any constant, and I mentioned it to you the other day that the constant is not necessarily only k, can be any alphabet, but let it be a capital letter. Is that clear? And we try to integrate sine x dx. When we integrate sine x dx, excuse me, we are supposed to have what? Minus cos x plus any constant, could be b. Then if we integrate cos x dx, we are going to have sine x plus any constant, true or false. Yeah, so I think with this, I'll be able to integrate any given function. Is that clear? Please try and wake others who are still sleeping. Yeah, who are still sleeping. It's okay. So let's proceed. Let us proceed further. Let us proceed to consider let's proceed. It's okay. You know that we'll be using the method called separation of variables. True or false? Separation of variables. Let me break it down for you before we go ahead to. When we say separation of variables, I want you to understand this before we begin to solve this differential equation. I want you to understand this. Separation of variables. It means variables could be x, y, or t, or theta, right? It could be b, or a, or c, true or false. But as long as calculus and mathematics is concerned, the most popular letters used are x and what? Y, true or false. The most popular variables used in mathematics are what? X and Y, right? So now, when they say using separation of variables, like this is a differential equation, dx equals to cos x, right? So it means before you can integrate this function, it means you have to separate the variables. The ones look alike should be in one side, and the other one should be in the other side. Is that clear? So now look at it. We have dy here. We have here dx equals to what? Cos x, two of us. So if I may ask you, cos x and dy, do they look alike? No. If we may say cos x and dy look alike, we are saying it is not true. But I want you to see with me and agree with me that dx and cos x, they look alike. They are like two of us. Just like you will hear somebody bearing Abdul, right? Abdul Musa. Can you see now? Then the other person will be bearing let's say, yeah, James Musa. Amen. James Musa. Then somebody will be bearing, let me say, Ima Osi. Can you see now? You see that these two looks alike, two of us. So it means they will be on the same side. Why this one, like John Osi? So why this one will be on the same side? You group them together. That is where you will be able to what? Integrate. Do you understand what I'm trying to say? Do you understand what I'm trying to say? Okay. So let's proceed. Let us proceed. Let us proceed. So when you look at this, when you look at this, all right, solution, right? When you look at this, our dy all over dx is equals to cos x. So we have to separate these variables. How? Look at the right hand side. Note that there is an invisible one. So we have to cross multiply. Use this to multiply this, then use this to multiply this. You will see that 1 times dy is equals to cos x times dx, right? Yeah. So 1 times dy is dy equals to cos x times dx is cos x dx, right? So can you see now we are able to separate the variables. So at this point we have to integrate both sides. We integrate what? Both sides. So we now say integrating both sides. So it means integral dy integral dy is equals to integral cos x dx. Can you see now? So when you integrate this side, we are supposed to have what? Y plus a constant, two of us. Please label this K1 equals to, since we are integrating both sides, equals to, when you integrate cos x dx, you are supposed to have what? Sine x plus any constant. But since we have used k, let it be k2. Do you understand? In some textbooks, this is what you are going to see. So, if you can see what I am saying, we take k1 to the right hand side, so our y will now be equals to sine x plus k2. If k1 crosses the sign of quantity, becomes minus what? 1. Can you see now? So now we don't need k2 minus k1. We can now say let k2 minus k1 be equals to what? K. And not necessarily k. We can use b here. So therefore our y is equals to sine x plus k. It's the same thing. But this is some textbooks. But you know, some textbooks will now, if they integrate this function, if they want to integrate this function, it's direct in some textbooks. If you integrate the y, you are going to have y equals to integrate cos x dx. You are going to have sine x plus, is direct. I'm just trying to, explain it deep so that, whenever you go and open a textbook and you come across something like this, you won't be surprised. Why some textbook will just give you the straight answer. Is there any question? Please ask. Any question? Oh, Samson. He said I should take it all over again. Samson, is okay. Okay, what I'm trying to say is, I know you are just coming. Say is this. Whenever you have been given a differential equation of this form, most especially first order differential equations, you are going to use separation of what? Variables to solve first order differential equations. Is that clear? So, since we are talking about separation of variables, it means that use that is, you try to take the like terms, you understand, collect just like your DS1, DS2, you were taught how to collect like terms. That is how it is. But here we have the 1 over dx, then here is cos x, but note that there is an invisible. So you just apply cross multiplication. Use this to multiply this. That is why you are seeing 1 times dy. Then use this to multiply. That is why you are seeing the right hand side cos x times dx. So 1 times dy is what? dy equals to cos x times dx is cos dx. So as it is now, you can now integrate both sides. That is why I said integrating both sides. So you can now see what? Since you said integrating both sides, you now introduce the integral. Integral dy equals to integral cos x dx. True of us? Yeah, it's true. So when you integrate the y, you are supposed to have y. Can you see now? Just go straight plus if equals to, if you integrate cos x dx, you are supposed to have sine x plus the constant. You just differentiate, integrate it straight. But I'm looking at this way. There are some textbooks you will open. This is how they will break it down. We know that when you integrate any function, you are supposed to have a constant, true or false. So as you integrate the y, you are going to have y plus k, true or false. But we are looking at both the right hand side and the left hand side. We are integrating both sides. So we now call this one k1 equals to integrate cos x dx. We are going to have sine x plus what? K2. So now we now take this k1 to the right hand side. That is why you now see that the left hand side will now be y equals to sine x plus k2 minus, because if this plus k1 crosses the sign equality, becomes what? Minus k1. So you now assume let k2 minus k1 be equals to k. So it means instead of k2 minus k1, you now write k. Y equals to sine x plus k. Why some textbooks will not, they will just, after here, they will just write here. Is that clear? Samson, are you following? Okay. Do you understand? Any other question? There is no question, we can proceed, right? Should we proceed or we should wait for Samson? Dada, you are following, right? So we can now proceed, right? Okay. So let us consider another example. Let's consider another example. Solve the differential equation. Okay. Let's consider another example. The other example is y. Is that clear? So what we are going to do, as we write solution, dy all over dx equals to y. So who can tell us what to do? As it is now, we have to separate the variables before integrating, right? So now, how can we separate the variable? We have to cross multiply. Let us first cross multiply. So when we cross multiply, 1 times dy is equals to y times what? Dx. True or false? Then 1 times dy is dy equals to y dx. True or false? Yeah, I know very well that some of this you want to integrate. It is impossible. Why? Because we have not been able to what? Separate the variables. How? Look at the right hand side. Look at the left hand side. Here we have dy. But the right hand side we have y dx. True or false? So this has nothing to do with x. True or false? So rather we push this y to this side. How? What are you going to do? We divide through by y. True or false? We now write divide through by y Is that clear? So it means dy all over y equals to y all over y dx. So this cancel. Can now have dy all over y equals to what? Dx. Can you see now? Are you following? Look at the board. Do you understand, right? Do you understand? Any question? Yeah, cross multiply. Nura. I love that. Any question? Yes or no? Elame. Any question? Okay. Yeah. So if there is no question, let us proceed. Let's proceed. Please try and wake others who are still sleeping so that they will be part of this class. The class is very few. The expected number is over 300, but it's only 20 something that are active here. That shows that people are not serious. It's okay. So let's proceed. Let us proceed. Let's proceed. So at this point, what are we going to do? We are able to separate the variables, two of us. So what we need to do, we write integrating what? Integrating both sides, right? So now the integral dy all over y equals to integral dx. Two of us. So if you agree with me, this means that I want you to note that dy all over y is the same thing as 1 all over y times dy. You know like that, right? Do you know like that? Okay. So it means we are integrating 1 all over y, two of us. So if we integrate the left hand side, this one we are going to integrate it straight, right? We are not going to have k1 and k2. Okay, so if we integrate dy all over y is the same thing as you are integrating, it means this is the same thing as integral, sorry, let me write the integral like a mathematician, 1 all over y dot dy, which is equals to integral dx. So it means this is the same thing as this whenever you come across something like this. But you know, we just do little revision, two of us. Yeah, I love you guys. Yeah, okay. So now we know that when we integrate, recall that if you integrate 1 all over x dx, what you're supposed to have? You are going to have in x plus what? Plus a constant. Two of us. True or false? True, right? Okay. So far, so this implies that we are going to have what? In y equals to, if we integrate dx, we are going to have x plus b. Do you agree with me? Please look at the board. I want you guys to look at the board. Do you agree with me? Any question, please? Any question? Abdurazak, I know you are just coming. You said I should come again. Musa Saad, you are just coming. Supposing you started the class with us, I don't think this will be a problem. Yeah, go back to our first class and what we just did before. I said if you integrate the y, it's going to give you y plus any constant. If you integrate the x, you are going to have x plus any constant to be k. Take note of this. These things are supposed to be in your head. Likewise, if you integrate the x all over x, it's just the same thing as what? 1 all over x. This will still give you x plus any constant. It could be g. Oh, sorry. In x plus any constant. Yeah. Is that clear? Is that clear? Okay. So if we integrate the y all over y, we are supposed to have in y plus any constant. It could be what? B. True or false? So I know you people are just coming. Is that clear? Then this is the same thing as integral 1 all over y times dy. True or false? So what is there again? What is there? Samson, are you following? Can we proceed? Is there any question, please? Is there any question? Yes or no? No question. Okay, so let us proceed. Let's proceed. Let's proceed. Is that clear? Let us proceed. Okay. It's okay. So let's proceed. So far, so good. I can claim this, right? So as it is, we are supposed to find uh, y, not in y. So if we take log on both sides, take log on both sides, right? On both sides. It means this is what we are going to have. We are going to have exponential in y equals to, excuse me, exponential b exponential x. This is what we are supposed to have. So this and this will cancel to give us the left hand side will be what? B exponential what? X. This is what we are supposed to have. So whenever you come across something of this one, just take log on both sides, then B exponential what? The X. So, is there any question so that we can proceed further? We can proceed further, right? Any question? Oh, Samson, you can't see it clearly. I think the network is from where you are. Sorry about that. Yeah, that is the final answer. Okay, I should throw more lights. I will do that. No, what I'm trying to say is if you come across equations of this form, we are looking for y, not in y. So you have to take log on both sides, natural log. The natural log is exponential. So this and this will cancel. We are going to have y equals to this b will multiply the exponential of what? Exponential x. Is that clear? So that is that. Okay, let's move further to consider some examples. Let's move further to consider some examples. Some examples that you may come across. Okay, yeah, let's continue. Let us continue. differential equation, we have the y all over the x, the y all over the x minus xy equals to x. Yeah. So let's look at it together. So who can tell us what to do? Somebody should help us. Our dy all over the x minus xy equals to x. Yeah, somebody should tell us what to do. Somebody should tell us what to do. Cross multiply. Is it possible? Cross multiplication will not work. Collect like terms. I love that. Collect like terms first. That is Emmanuel. I love that. So if that is the case, we now collect like terms. Collect like terms, right? Okay. So when we collect like terms, it means minus xy will now be equals to, crossing the sign of equality becomes what? So here will now be our dy all over the x, now be x plus xy. True or false? True or false? Look at the board. True or false? Yeah. True or false? Somebody should answer me. Emmanuel. Yeah, I love that. Emmanuel, you are following. Plus. Yeah. True. Right? Okay. So, what are we going to do? We now cross multiply, right? So it means this one will multiply this. So 1 times dy is equals to this x plus xy dx, right? Okay, so this one will be, the left hand side will be dy equals to yeah, let's look at this. What is common here? What is common? X. We can factor x out to be either open bracket 1 plus y x dx. True or false? True or false? True or false? So you don't need a prophet to tell you. Do you need a prophet to tell you? No. You don't need a prophet. You don't need a prophet. Okay? So if it is true, right? If it is true, false, sir. Oh, how? Abdurazak is asking for, sir. How? Oh, I know you are blind mathematically. Okay, ordinarily, when we have x plus xy, ask yourself, what is common inside this bracket? Is it not x? X is common, you factor it out. Here will be 1 plus y. By the time you multiply this bracket, x times 1, is it not x? Plus x times y, is it not xy? Abdulrazak. Okay, what are we going to do? We have to divide through by plus. So it means we are going to have dy all over what? 1 plus y equals 1 plus y, close bracket, all over 1 plus y x dx. True or false? This and this will cancel. So we are going to have dy all over 1 plus y equals to x dx. Any question? Please look at the board. Look at the board. If there is any question, please let me know. If you have any question, let me know. Let me know of any question. Musa Sahad, you're asking me to come. I have explained it now. Where? Musa, please talk to me. Musa Sahad. Where do you want me to explain? Musa Sahad. From that collecting of like terms is okay. Oh, collect like terms. That is where you are not clear with. This is xy equals to x. So you cannot separate x and y. Yeah, to be minus x plus y. It is impossible. This is how it should be. So by the time this minus xy crosses the sign of equality, it becomes what? X plus xy. Because this one is coming to meet this x. So minus, they are crossing over to meet this x. So since here is minus, here will be plus x plus xy. Then you cross multiply. When you cross multiply this to this, then this to this, you are going to have this 1 times dy, true or false, then equals to x plus xy times dx. Look at it. So now you now factor out, before you be able to integrate, you factor out what is common here, x, true or false. So when you factor out x, this is what you are going to have inside the bracket. 1 plus y, close the bracket, x dx. Then we cannot integrate this as it is, because the right hand side, you are still seeing y mixed up with x dx, true or false. So you need to divide through by what? 1 plus y. So when you divide through by 1 plus y, this is what you are supposed to have. This and this will cancel to give us what? X dx. Then finally we are going to have dy over 1 plus y equals to x dx. So we are able to what? Separate the variables, true or false, and that is where we can integrate both sides. True or false? True or false? Do you understand now? Do you understand now? Yes or no? I think you are just coming. Go on. You did not start the class with us. That is why you are asking these questions. Go on. You are just coming. A late comer. We are using separation of variables. Go on. So we need to separate the like terms. Yeah, you are just coming, and You are late. How many minutes? Late. So we will look at it in the class. Go on. Is that clear? You ask me in the class, I will explain it to you. Make sure you write that question down. So when I come to class, Nura, Zimo, you are asking where is the third X? Which one is the third X? Don't you see what I did? I factor out the X. No, we are not done. I'm just trying to answer. Buhari, we are not done. I'm just trying to answer people's questions. It is not yet done, please. First from Kano. Good. Enjoy yourself. So you are watching from Kano to Abuja. You are on your way. Abdulrazak. Is there any other question so that we can proceed? Any question? Yes or no? We will integrate. Baba, Lola, we will integrate. I'm just still attending to questions. We will integrate. Any other question so that we can move on? Hope you are enjoying the class. Okay, so let's progress. Let us progress. Let us progress. Let us make progress. Okay. So now, at this point, I want you guys to note, please. Note that. Note that. Note that when you integrate 1 over x plus 1 dx, you are going to have in x plus 1 plus any constant. Do you agree with me? Please take notes. Take notes. Or let's look at it together. Or what you need to do is you use substitution and let u be equals to x plus 1, use substitution. So du all over dx is going to give us what? It's going to give us 1. So our du will now be equals to, when we cross multiply, we are going to have dx as 1 times 1, right? Okay, so it means this integral will now be 1 all over u dx. Our dx, 1 times dx is equals to du. It's going to be what? Du, right? So this is going to give us what? To integrate this, we are going to have in u plus any constant. But it's the same thing, two of us. Because by the time you recall your u is what? X plus 1 plus k. So it's the same thing. So take note. Either I use substitution or you just write it straight in x plus 1 plus this. Take note. Because I know you are not seeing what I am seeing. You are not seeing what I am saying. So if here we have, now here we have what? Dy all over 1 plus y equals to x dx. This x dx, right? When we integrate both sides, this is how it will be. True or false? So if we integrate this side, we are going to have in, we'll have in, we'll have in y equals to x raised to the power of 1 plus 1 all over 1 plus 1, true or false, plus k. Then, oh, what am I writing? Sorry. In open bracket 1 plus y, yeah. Then here will be x raised to the power 1 plus 1 all over 1 plus 1 plus k. True or false? Look at the board. True or false? True or false? Is there any question? Please ask before we proceed. True, right? Okay. Those that started the class, Mohammed, I know you are just coming. Aliu, you are asking me to repeat. How did we get this K? So unfortunate, Musa, Saad, I think he did not start the class with us. Our first class here will tell you how we got the K. Because we are integrating. Whenever you are integrating, you are supposed to have a constant. That is why you are seeing the constant on the right hand side. That's why you are seeing the constant, the right hand side. I told you people that when you integrate any function x dx, you are going to have x raised to the power 2 all over 2 plus any constant. It could be b, true or false. So if you have something like this, what do you expect? You should have the constant. Do you agree with me? Okay. So here we are going to have in open bracket 1 plus y equals to x 1 plus 1 2 all over 2 plus the constant. So now I'm going to stop here, but I want you to find y. Is that clear? I want you to find y. I want you to find y. So that is what I'm going to leave as what? An assignment. I want this y to be equals to something. This is an assignment. So I want you to finish it. Is that clear? On Monday I'm collecting it. You are submitting your assignment on Monday. Your assignment on Monday. So I want your assignment to y equals to. And what is that? So, thank you and God bless you. Have a wonderful weekend. Love you guys. Bye. Please don't forget to share, like, make sure you do the needful. Love you guys once again. Yeah. Amen.